In this video, we're going to talk about how to simplify rational expressions. There's a three-step process that we're going to go through, and the first step is to factor, the second step is to cancel, and the third step is to state all values which make the rational expression undefined. When you see the phrase rational expression, what I'd like you to do is I'd like you to think of fractions. Rational expression is just a fancy way of saying fractions, and the fractions that we're going to be working with have polynomials in the numerator or the denominator or both. So we're going to begin this lesson with just a real simple fraction example, something that we've done in the past that we should be familiar with. I'm going to take 10x cubed divided by 15x squared. I'm going to break this down. I'm going to rewrite this as 5 times 2 x times x times x over 5 times 3 x times x. And we're going to reduce all of the factors of 1 that we see. I notice I have 5 divided by 5. 5 divided by 5 is 1. I can cancel that. I also notice I have an x in the numerator and an x in the denominator. And here's another pair of x's that I can reduce. And then I gather the leftovers. The leftovers in this case are 2x over 3. Now this last thing that I asked you to do, where you're stating the values that make the rational expression undefined, this is going to happen when we are dividing by 0. Remember, when we divide by 0, our rational expression is undefined, or any fraction is undefined. So in order to state when that happens, what I want you to do is I want you to look at the original problem and say, okay, when would that be 0? Well, for this example, we have to add the condition that x cannot equal 0. Because if x is 0, this rational expression will be undefined. Let's go ahead and do one that is a little bit more complicated. This one's going to involve factoring, and you're going to find that in this unit, factoring is a key element to getting these rational expressions simplified. I look at this problem here, and I notice that x squared minus 4 is difference of squares. And when I factor this numerator, it's going to factor x plus 2 times x minus 2. When I factor the denominator, that's going to factor x plus 3 times x plus 2. Again, we're looking for a factor of 1 that I can reduce this fraction with. Well, here's an x plus 2 in the numerator. I can reduce that with this x plus 2 in the denominator. Then I'm going to gather my leftovers. In the numerator, I have x minus 2. In the denominator, I have x plus 3. And then we ask ourselves, when would this rational expression be undefined? We want to state what x cannot be in this case. So we're going to add this condition, and we are looking at the factored form of the denominator, and we're going to say that x cannot equal, sorry about that, there we go, x cannot equal negative 3 or negative 2. Both of those values would make this rational expression undefined. Let's do, and this would be my answer in simplified form. Let's do another one. I look at this, I recognize that we have difference of squares again. So I'm going to factor difference of squares. When I factor the numerator, it's going to become x plus 5 times x minus 5. The denominator is going to factor x minus 5 times x minus 5. Again, we can reduce by a factor of 1. I can cancel out these x minus 5s. I gather the leftovers, and the leftovers are x plus 5. Whoops, I don't necessarily need the parentheses here. It's going to be x plus 5 divided by x minus 5. And then I want to state any restrictions that I have. I'm looking at the factored form and asking myself, when would that denominator become 0? Well, that denominator becomes 0 when x is positive 5. So I'm going to just add here that x cannot equal positive 5. And this would be my final answer. I want to talk about one thing though. A lot of people something I see every single year. I know you guys aren't going to do it, but people in the past have done it, so I want to address a common error that people make. A lot of people would look at these problems and say, wait a minute, you can reduce that further. There's an x in the numerator and an x in the denominator, and you can still cancel that. But you cannot. If I look at this first answer, x minus 2 over x plus 3, if you look at this and say, oh, well, here's a factor of 1, I can cancel those x's, that is bad, bad news. We can only cancel products. Very, very important here. You can only cancel products. So if you can't write it as a product, which we do by factoring, you can't simplify it further. Looking at this second problem, I know I can't reduce this further because this is x plus 5. This is a sum. This is x minus 5. This is a difference. These are not written as products. I can't go on. Let's do another one. I'm going to look at this problem. I recognize that this numerator here is the sum of cubes. Now, for sum of cubes, we might not remember that formula, but it's still good practice. We have this factoring pattern that we're going to follow, and the factoring pattern is, I'm actually going to erase that so I have a little more room to work here. It's a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So then I have to figure out what my a and my b are. In this case, my a is going to be x squared. My b is going to be 3. Remember, x squared raised to the third power gives me x to the sixth. 3 to the third power gives me 27. So I'm going to fill in this factoring pattern with the x squared and the 3. And every place I have an a, I'm going to use x squared. Everywhere I have a b, I'm going to use 3. The denominator, you might think that the denominator here is difference of squares, but it's not. It's, well, here's a square, but 3 is not a square. I can't really do anything with this, so I'm just going to leave it as is. So when I simplify this, I have x squared plus 3 times x to the fourth minus 3x squared plus 9 over x squared plus 3. I'm looking for anything I can reduce here. I can reduce by a factor of 1. X squared plus 3 divided by x squared plus 3 is 1, so that can cancel. And what I'm left with is simply x to the fourth minus 3x squared plus 9. In this case, the restrictions that we have for x, there we go. The restrictions that we have for our denominator here, x squared plus 3 equals 0, x squared equals negative 3. If I look at this, I'm going to have an imaginary number. So there really are no values that are off limits here. In other words, there's no real number that will make this become 0. So there are no restrictions for x. Okay, let's do another one. I'm looking at this. Now, x squared plus 4, I want to factor that. But this is not difference of squares. This is actually sum of squares. And I can't factor sum of squares. Which means, since this is not factorable, since that's not factorable, it's already in its simplest form. So all I can do here is just say that it's x squared plus 4 over x plus 2. It's already reduced. I do have the restriction, though, that x cannot equal negative 2. And that concludes our simplifying rational expressions. Thank you so much.